So the following questions refer to the vectors u, v, and w. And the first thing is to find a vector A, which is equal to 3u minus 2v plus w. So let's write that out. Now, our vectors u, v, and w have already been provided to us in I, j, and k form. So this should be as simple as substituting in those vector representations and then simplifying the expression. So, u, we can substitute in this, minus 2, and then v, substitute that in, and then w as well. Alright, so I might expand out those brackets to make it a little bit easier. So 3 times 2 gives me 6 and an I, 3j from that one, and then 3 times negative 3 gives me negative 9 with a k. I'm then going to have negative 2 times 5, so negative 10i, negative 2 times 2j leaves you with negative 4j, and then negative 2k. And then the last one I can pretty much just copy out. Alright, so let's collect all the i's together firstly. So we're going to get 6i minus 10i, so that leaves us with negative 4, and then plus 4, so that's going to go back to 0. So all of these cancel themselves out, so a 0 I component. We've then got 3j minus 4j, so that's negative 1j, plus 2, that takes us back to 1, so this will be 1j, and then negative 9k minus 2, that leaves us with negative 11, minus 6 leaves us with negative 17. So that there is the answer to part A. So part B is to determine a vector B, which is the cross product of v and w. So let me write that out. Alright, so I'll substitute in our two vectors. Alright, so when doing our cross product, of course we're going to end up with cross products of those unit vectors as well. So there's the little diagram we can draw ourselves to help with the positives and negatives of those. Remember, if you do a cross product in the direction of the arrow, it's going to be positive. If it's the opposite direction, it's going to be negative. So let's start with 5i and multiply it through the other bracket. So we're going to get 5i crossed with 4i to start with. Now we know that a vector crossed by itself is going to be 0. So I cross I here is 0. So that's all that one works out to. We've then got 5i crossed with 2j. So 5 times 2 is 10. And then I cross j, that's in the direction of the arrow, so it's going to be positive. And we end up with the other one. So that's going to be a k. We've then got 5i crossed with negative 6k. So 5 times negative 6 is negative 30. And then we have I cross k. So that's in the opposite direction to the bracket, so it's going to be a negative. That means we're going to end up with a double negative. So that's a positive. And then we end up with the other one. So that's going to be a j. Alright, so now we're up to multiplying this 2j term through the other bracket. So 2j crossed with 4i. 2 times 4 is 8. J cross I, that's going to be in the opposite direction to the arrow, so a negative, and we end up with the other one, so that's a k. We've then got 2j crossed with 2j. Now we said a vector crossed by itself is 0, so that's what that one is. And then we have 2j crossed with negative 6k, so 2 times negative 6 is negative 12, and then j cross k, that's in the direction of the arrow, so it's going to be positive. That means the sign won't change. And we're left with the other one, which is I. Alright, so last one is multiplying this k through the other bracket. I might do it on the next line here. So k cross 4i, so that's like 1 times 4, which is 4. K times I, that's in the direction of the bracket, so it's going to be positive. And we're left with the other one, which is a j. We've then got k crossed with 2j, so 1 times 2 is 2, and then k cross j, that's opposite direction, so it's going to be negative, and we get the other one, so an I. The last one, we've got k crossed with k. Again, a unit vector crossed by itself is going to be 0. So 0 on the end there. Alright, so now we can put the I, j and k components together. So start with I. We've got negative 12 minus 2, so that's going to be negative 14 overall. For the j's, we've got 30 and then plus 4, so that's positive 34. And then for the k's, we've got 10 minus 8, so that's going to be plus 2 overall. So that there is our answer to part B. So next up we have part C, which is to show that B and V are perpendicular to each other. Now we know that this should be true simply because B was the cross product of V and W. So we know that when we do a cross product, what comes out needs to be perpendicular to each vector that was included in the cross product. So that means that B should be perpendicular to V, and it also should be perpendicular to W. If you want to draw kind of a generic picture, I'm not going to draw these specific vectors, but just pretend we have a V and a W, which look like this. When we apply the cross product, it should be, if this was B, 90 degrees to these two. So there should be a right angle in here, and there should be a right angle in here. Alright, again, if that doesn't happen, then something has gone wrong in your calculations. So, for part C, what we were interested in was specifically B and V, and one way we can prove that something is perpendicular is to show that the dot product of those two vectors is equal to 0. Okay, if that's true, then they're perpendicular. If it's not true, then obviously they're not perpendicular. So let's apply our dot product. I'll substitute these in. So B, we've just worked that out here, so negative 14i, 34j, and 2k. So that gets dotted with our B vector, which was this here. I'll just steal it. Alright, so remember for a dot product, all we're doing is multiplying together the I components, the j components, and the k components, and then adding them together. So we're going to get negative 14 times 5, plus we've got 34 times 2, plus 2 times 1. So putting this together, that one's a bit big, I might put that in a calculator. And if I do that, I end up with negative 70. The next one is 68, and that's 2. So negative 70 plus 68 plus 2, they're all going to cancel out with each other, and I'm just going to be left with 0. So the fact that this came out to 0, that's what shows that those two vectors are perpendicular to each other. Alright, so part D. We're asked to show that U and W are perpendicular to each other. So let me just quickly write them out here. So U is 2i plus j take 3k, and W is 4i plus 2j minus 6k. So one way that we can show that two vectors are perpendicular is we can try and factorize out some scalar or some number and make one vector equal some scalar multiplied by the other vector. And if that's true, then those are indeed parallel, sorry. Alright, so let's try and do that. So W is the bigger one. So I might make that one equal. So we want it to equal some number. I'll call it alpha, but you can call it anything, multiplied by U. Okay, so if this is true, we have actually some number that can slot in here, then those vectors are indeed parallel to each other. So let's substitute this in. So it's 2i plus j minus 3k. So we need this to equal this vector here. So this one's pretty easy, alright? If I set alpha to be equal to 2, what I'm going to find is that it's going to end up equaling W. So expanding this out, we get 4i plus 2j, minus 6k. Alright, and that is exactly what W is equal to. So since we can express our two vectors in this form with just a constant out the front, that tells us that these are indeed parallel to each other. So that's all there is for that question, and I'll see you in another video.